Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 12th grade topic, arithmetic sequences. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what you see today or even on homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 12th grade playlist, in which I cover a lot more topics. So if you're interested in that, make sure you stay tuned. This video is going to have 4 parts, so leave a like, smash subscribe, and let's get started. To begin, let's first talk about what a sequence is. Now, a sequence is just going to be a list of numbers. Now, that list, it doesn't matter if it's a finite list or an infinite list. It doesn't matter. It could be an increasing list. It could be a decreasing list. It doesn't even have to be either of those, as long as it's a list of numbers separated by commas. Now, before we talk about what makes a sequence an arithmetic sequence, let's see if we can find the next terms for these two sequences here. Looking at our first sequence here, we have 35, 32, 29, and we're trying to figure out what that next term is. Well, the question you want to ask yourself is, can you find the pattern? Is there a pattern here that jumps out at you? Well, looking at this, going from 35 to 32, we see that we're going to be decreasing, right? A decrease of 3. How about from 32 to 29? Well, from 32 to 29, we're going to be decreasing by 3. So if we were to assume the pattern continued, we would decrease by 3 again, and what would be our term? Well, this would be 26. Okay, how about this one? We're starting at 9, and if we were to go from 9 to 14, we are going to see we're increasing by 5. How about from 14 to 19? We're going to increase by 5. Now, assuming the pattern continues, what will we get? If we increase by 5, we're going to have 24. These two patterns are what we call arithmetic sequences, and that's because there's a fixed difference between one number and its preceding number. So you see that there's a fixed difference between this 32 and the number before it, a negative 3. 29 and the number before it, a negative 3. 26 and the number before it, a negative 3. And over here as well, 14 and the number before it, 5. 19 and the number before it, 5. 24 and the number before it, 5. There's a fixed difference between a number and the number right before it. But assuming this was a 31 instead, right? If this was a 31, then you would have a difference of negative 4 here, and this difference would be a negative 2. This is not an arithmetic sequence because it's not a fixed number. It's jumping around. You have negative 4, negative 2, and then negative 3. This is not a fixed number difference. Therefore, you don't have an arithmetic sequence. It has to be a fixed number. So if you have something like this, you're going to have an arithmetic sequence. Now that we know what makes a sequence an arithmetic sequence, let's talk a little bit about some notation. So some notation that's going to be common for most, if not all, of your sequences is going to be the following. We have n's, we have d's, and we have a sub n's. Now, d's are going to be the difference you see up here, right? So this was negative 3. So in this case, the d was going to be negative 3. Up here we had 5, so the d would be 5. So d is just going to be your difference, right? And it's going to be the term that you're on. So this is our first term. So n would be 1, n would be 2, n would be 3, n would be 4. So n is just going to be the term that you're on. So the term you're on, or even the term you're looking for. A sub n is going to be the value of that term. So a sub 1 is going to be 35. So a sub 1 in this case is 35. A sub 2 is 32. It's the value at this nth term here. And you can do the same thing over here. Your a sub 1 is 9. Your a sub 3 is 19. But let's say we want to develop a formula to help us find the nth term of our sequence. Let's say it's the 20th term or the 50th term or the 80th term, and we don't want to have to draw out our entire sequence to do so. Can we find or create a formula to help us do this task? Well, the answer is going to be yes. We actually have two formulas that should help us find the nth term of an arithmetic sequence. The first formula is going to be called the explicit formula. The second formula is going to be called our recursive formula. Now, the difference between the two is that our explicit formula will help us find an nth term directly. We don't need to know what came before it. We just need to know pretty much some basic information about our sequence, and then we can find the nth term directly. We can go straight to that nth term. Our recursive formula takes a little bit more work. It's actually what we did here, except in formula form. So let's jump into our next part of the video, in which we take a closer look at trying to develop this explicit formula. So let's try to find our explicit formula for our first sequence that we talked about. Taking another look at that first sequence, we have 35, 32, 29, and 26. We already know that our D, in this case, is going to be a -3. We're going to be adding -3 to each number to get the next one. How do we find this 26? Well, we started at 35, right? So we wanted to find, and remember, this is our fourth term, our n equals 4. So if we want to find a sub 4, which we know to be 26, we started at 35, right? And then we added -3 a few times. How many times exactly did we need to add -3 to get from 35 to 26? Well, -3 was added 3 times, right? So we had a -3, and we added it 3 times. And by doing that, we got our fourth term to be 26. If you were to try to find your 29th term, right? Assuming they didn't give it to us, this would be our third term, so a sub 3. We would start at 35, and we would add our D, our difference of -3, how many times? Well, we would add it 1, 2, so 2 times. And that would give us a 29. If we were to try to find this one right here, this is our second term, which would be a sub 2. And once again, you're starting at 35. How many times will you add your difference to get to 32? Just the 1. So you have this right here. Do you notice a pattern here? Well, if you're trying to find your fourth term in this case, you're going to be adding your difference 1 less than that, right? So we did 3 when we're trying to find our fourth term. We added it twice when we tried to find our third term, and we added it once if we're trying to find our second term. So we can actually generalize this into our explicit formula by doing the following. Let's say we had some nth term that we're trying to find, a sub n. We know for this case, we're starting at 35, and we're going to be adding repeatedly our -3. But in order to find the nth term, you're going to have to add -3 how many times? It's going to be that n minus 1. That's exactly what we just did. Remember, to find our fourth term here, we added our D 3 times. To find a third term, we added it twice. So to find our nth term, we're going to add it n minus 1 times. Now you can distribute this. You're going to have 35 minus 3n plus 3 here. So a sub n is going to be 38 minus 3n. This is our explicit formula for this sequence. You can plug in any n to find the nth term, the value at that nth term. So let's say we want to find the nth term, the value at nth term where n was 10, right? 10. We want to find what is our value. Now we don't need to write out 9 values for the sequence to find our nth term when n is 10. We can simply plug in 10 and figure out what a sub 10 is. So we're going to have 38 minus 3 times 10, and that means that a sub 10 is going to be 38 minus 30, which gives us an 8. So we know our 10th term, our a sub n, is going to be 8. This is the beauty of our explicit formula. We don't have to figure out all the terms preceding. We can go directly to the term we're looking for. Now that we talked about our explicit formula, let's figure out how to create our recursive formula. So when writing your recursive formula, you're usually going to start with a starting term. That starting term is typically your a sub 1, right? A sub 1 in this case is going to be 9. Now remember, we said that in order to get to this 24, we had to add 5 to it, right? So a sub 2 is going to be this 9 plus 5, right? And we found out to be 14. And what do we do from there? Well, we added 5 again, right? So a sub 3 was this 14, and we're adding 5 again, right? So 5 plus 14 gives the 19 here. And then we added 5 again here. So a sub 4 was this 19 plus 5. You see, you're just constantly adding this 5 to the previous term here. And you should be able to see how this formula works now, right? So if you know what your starting point is, you can just plug that in, add your difference like we did here. We started here at our 9, added our difference, and we found our second term. We're going to then take that second term, plug it in here to find our next term by adding the same difference. And you're going to keep doing this, hence why it's called recursive. You're going to keep doing the same thing, plugging in what you previously found and adding the difference. Notice that using the recursive formula does depend on knowing what the previous value was. So finding the nth term is going to be a little bit more work than if we were to use our explicit formula. But if you were to try to find a nice, easy way of telling someone how to fill out the rest of a sequence, an arithmetic sequence, this recursive formula is a nice way of doing it. You would start at some a sub 1 is going to be some number, let's say some number k, and your a sub n is going to be a sub n minus 1 plus your distance. So k is going to be some number. You're just given some number. It doesn't have to be a sub 1. It's just typically a sub 1. But don't think that you have to have your starting point. You can have any number in this sequence and it'll be fine. But typically you might see this a sub 1 here. And then your formula is going to be a sub n equals a sub n minus 1 plus d. Now, before we jump into our example for today, there's one quick thing I want to run by you. Now, you may run into some notation in which uses the n plus 1 and the n here, just like this. This is saying the same exact thing. Instead of a sub n equals a sub n minus 1, they're just moving it up 1. But it doesn't matter. They're saying the same thing. Notice n to n minus 1 and n plus 1 to n is just one term difference. As long as you're keeping that one term difference, you're saying the same thing. Now, if you start seeing something like this, that's not saying the same thing. You're two term difference apart. You just want your n plus 1. It doesn't really matter if it's this way or that way. They're saying the same thing. No need to get confused. So in our example for today, we want to find both our explicit formula and our recursive formula for this sequence. Now, of course, you want to make sure this sequence is an arithmetic sequence, which is going to be for this example, but you should always check. You don't want to do work that you don't necessarily have to do and get a wrong answer, assuming it's something it's not. So normally check, but this is going to be an arithmetic sequence, so we want to find both the explicit and the recursive formulas for this example. Now, the first thing we want to do is find our differences. So going from here to here, we see that this is going to be a negative 30. Going from here to here, it's also a negative 30, and going from here to here, it's also a negative 30. Once again, we knew this was going to be an arithmetic sequence. It should be fixed. It shouldn't be changing. So we have our D now. Our D is going to be a negative 30. It's decreasing by 30. Don't get it switched. Don't put 30 because it's decreasing. You have to make sure you keep the correct sign. Our D is going to be a negative 30. I'm going to put it up here instead. Negative 30. D is negative 30. Now, we're trying to find our explicit formula. So I'm going to say this is going to be E, and this is going to be R. When trying to find our explicit formula, remember, our A sub n, we're going to start at this first term here, negative 34. And we're going to add our D. Remember, it was A sub n, right, equals our A sub 1 plus D times n minus 1. This was our formula. Let's find it for this. We have our A sub 1, which is negative 34, plus our D. Our D is negative 30, so we're going to have minus 30 times n minus 1. You just write that n minus 1 in there. You don't have to do anything else with that. Now that we have this, we can distribute. So if we were to distribute, we would have our negative 34 minus 30n plus 30. And if we were to combine like terms, we would have negative 34 plus 30. Well, let's say we have a negative 30n minus 4. This is going to be our explicit formula. And you can test this out. If n was 2, you would see you have negative 60 minus 4, which gives you a negative 64. We have our explicit formula. Now let's make our recursive formula. Remember, we have to start with something. So might as well start with A sub 1, which we know to be a negative 34. In order to find A sub 2, we would do negative 34 plus our D, which is going to be 30. In order to do A sub 3, we would do negative 64 minus the same 30, which gives us a negative 94. So our A sub n is going to be what? Well, it's going to be our A sub n minus 1 minus 30. This is going to be our recursive formula given that we know our A sub 1. So I hope you were able to follow along with this video, and I hope you now understand your basics of arithmetic sequences. However, if you have any questions about what we saw today, or even your own homework, you can put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It surely helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share the video with a friend. Well, that's all the time I have for today. I really hope this helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney, here's your playlist, and this has been another session of Tutor Me Sempai.